Hello and welcome to Math 128, Lesson 12.3, Probability and Odds. So today we're going to be talking about probability, and then we will move to odds as a conversation piece. So in example 1, it says a coin is tossed twice. What is the sample space for this experiment? So if we're talking about a coin, remember that coins have one side that's heads and one side that's tails. So our sample space is going to be either heads followed by heads, as I flip it twice, heads followed by tails, tails followed by heads, or tails followed by tails. So there are 4 possible outcomes. When we do probability of any event, one of the most important things is the number of favorable outcomes over the number of possible outcomes. So as we're looking at this, we want to think about how many ways can what I want happen and how many ways can anything happen. And so those are our 2 values we're going to be looking for. So we're going to think about our sample space, what is possible, and our event, what we want. Remember, those events are like little subsets of the original sample space. So we're having a fair die. It is rolled once. What is the probability that an odd number will show up on the upward face? So again, remember, anytime we talk about a dice, or a number cube, we assume it is a 6-sided die. And only if it says 8-sided, 10-sided, etc., will there be a difference. So as we're thinking about this, our possible outcomes are 1, 2, 3, 4, 5, or 6. And then if we think about odd numbers, that's the event. That would be the numbers 1, 3, or 5. So the probability of our event occurring, the odd numbers, how many odd numbers are there? There are 3. How many possible numbers are there? There are 6. And then we will always simplify any fractions and write them in lowest terms or reduced form. So 1/2 is your answer. All right, for example 3, we're going to be looking at 2 fair dice being tossed. And I've included a picture here for you. Again, you would need to recreate this for any problem you were asked. So think about how it's created. So if the 1 comes up, I can have a 1 and a 1, a 1 and a 2, a 1 and a 3, all the way down to 1 and 6. If the 2 comes up first, then I could get a 1, then a 2, 3, all the way up to 6. So there is a total here of 36 possible combinations of what could happen. So it says, what is the probability that the sum of the pips, those are the little dots on the die, are on the upward faces and they equal 7? So think about which sums equal 7. Well, if I'm looking at this picture, to get 7, I would have 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. So if I wanted to write down all of the possible, then I would write down all 36 combinations. We're just going to look at the chart for that. And then my event are the pairs that add up to 7. So I'm going to write them as ordered pairs. So 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. And one thing we're assuming in this is that we can tell the difference in the dice. So in my picture, notice I have a white one and a colored one. So that allows us to tell the difference in which one happened first. So how many of these where we rolled a sum of 7 are there? 1, 2, 3, 4, 5, 6. So our probability of our event occurring is equal to 6 out of how many possible? In this case, 36. And then again, we want to simplify, reduce, or write in lowest terms all of our fractions. Okay. All right, let's look at the next problem. For this problem, we're going to be looking at a table. And there are tables in the book that you are going to be looking at. There are tables in the homework. So this one, you can only see the parts that I need you to, but I'll go ahead and talk to you a little bit about what's here. It says, using the data from the table, what is the probability that a randomly selected person is between the ages of 39 and 49? So first of all, the most important thing we need in any table is the total number of items. So that is this final number. Hopefully you can see this says total here, total here. That total number is 3,228. So I'll write that right here. Total number in the table, 3,228. And then the people that are between the ages of 39 and 49. Well, in this table, that's this row right here. And you may be able to see it. It may be really hard with the document camera. So I'm going to rewrite that number. The total number of people in that age category is 773. So the probability of our event, which is the people in this age group, is 773 over the total number, 3,228. Now this one's not going to simplify easily. So one of the things that you might need to do, depending on the problem, is go ahead and change it into decimal form. So to do that, we're going to do top divided by bottom, just like we were doing in the last lesson. And so grab your calculator and take 773 divided by 3,228. And hopefully you got 0.23946711623. Again, anytime we're dealing with decimals, we're going to use a rule of thumb of 3 decimal places unless it tells us otherwise. So this answer is going to be 0.239. Again, if we want an exact answer, then we're going to leave it in the decimal form. This is an approximate answer. When you're doing your homework, if it asks for an exact answer, leave it in fraction form. Again, you need the total for what we want and the total possible. All right, let's look at the Punnett square below. If any of you are chemistry students, this should look familiar to you. If not, you'll catch on. For a certain type of hamster, the color cinnamon, capital C, is dominant. The color white, lowercase c, is recessive. If both parents are capital C, lower c, what is the probability the offspring will be white? So let's look. This would be parent number 1, big C, little c. This is parent number 2, big C, little c. And then think of this as like a multiplication. So big C times big C is big C, big C. Big C times little c would be big C, little c, and so forth. Little c times little c would be little c, little c. This is the one that is white. This would be a cinnamon colored. And then these two would be some sort of mixed color. So what is the probability that the offspring will be white? So let's put a little note. CC is white. And then the probability of the event, that is getting an offspring that's white. There is 1 in the table out of the 4 possible. And again, that's in lowest terms, so we don't have to reduce or simplify. All right, so probability, think. Number of possible is your bottom number. Number of what you want is your top number. Now we're going to switch gears and talk about odds. You've probably heard the word odds, and usually when people are talking about it, they sometimes use it interchangeably, but it is not the same thing. So as we look at odds, I want you to think about what you've heard before, and then we'll kind of fill in the gaps of what's different. So here are my definitions. Again, these are in your e-textbook or in the book PowerPoints if you want to see all of this work again. The odds describe the likelihood of an event as a ratio comparing the number of favorable and unfavorable. So think back to our previous page, and we did probability. So probability is the number of favorable, what I want, over the number possible. Here, notice my 2 words I'm doing are favorable and unfavorable. So odds can be in favor of something or against something. So looking at these definitions, we'll use them and answer this question, example 6. If 3 red, 4 white, and 5 blue balls are placed in a box, 1 ball is randomly selected. What are the odds against the ball being blue? So odds against, the number of unfavorable outcomes is on top. The number of favorable is on bottom. So odds against our event E. So what is the odds against it being blue? Well, there are 5 blue balls. How many are not blue balls? That would be the 3 red and the 4 white. So there are 7 that are not what we want and 5 that are what we want. We want this to be in ratio form. A ratio comparing the number of favorable and unfavorable outcomes. A ratio can be written as a fraction, or we can use the little colon between it. A ratio is a comparison. Okay. In the center here, I have a little paragraph out of the textbook. Odds express the likelihood of an event. And then it says the relationship between odds and probability is as follows. Suppose that E is an event in a sample space, and the odds in favor of something are A over B. Then the probability is A over A plus B. So let me tell you this way. If the probability of something happening is 1 out of 5, that means 1 is favorable and 5 is the number possible. So if we want to convert this to odds, then we have to think about what that means. There's 5 total. 1 are what we want, or favorable. And that means that 4 would be unfavorable, because favorable plus unfavorable have to total the possible. So if the probability of something happening is 1 out of 5, then we can do odds for and odds against that happening. Odds for it are the favorable over the unfavorable. So favorable is 1, unfavorable 4. Odds against are unfavorable over favorable. So unfavorable on top, 4 over 1. The second sentence I kind of wrote over says, suppose that E is an event in a sample space. The odds in favor would be, I'll rewrite it here since I wrote over the top of it, the probability of E over 1 minus the probability of E. So again, this is going to be our formula for odds in favor. And we're going to use that for our next example. Go ahead and push this up just a little so you can see both. For example 7, it says a report issued by the Southern California Earthquake Data Center estimates that the probability of an earthquake with magnitude 6.7 or greater within 30 years in the San Francisco Bay Area is 60%. So the probability is 60%. Then it asks, what are the odds in favor? Odds in favor of an earthquake occurring in the next 30 years. So remember, our odds in favor of something are the favorable over the unfavorable. Or the probability that the event occurs over 1 minus the probability that the event occurs, using our formula that we just were told. So let's look at the probability here. 60% is the same as 0.6 as a decimal. This is 60 out of 100, or 60 hundredths. I'm going to use the 0.6 version in this formula. So the probability of the event occurring is 0.6. 1 minus 0.6 is going to go on the bottom. So I have 0.6 over, go ahead and subtract. Hopefully you got 0.4. And then we're going to take top divided by bottom to get rid of the decimals. And then hopefully your calculator gives you 3 over 2 or 1.5. And we want to leave it as the comparison. So 3 over 2 Or, of course, we can use the dot 3 to 2. So look at that formula, and when we're going to use it is when we are told the probability and we're asked to find odds in favor. When we're told the probability and we want to find odds for something and odds against something, we're going to use the total possible and subtract the number of favorable to find the number of unfavorable. And then we can fill out both of those as well. As you're going through your homework, remember that if you miss it once and you know what you did, try it that second time. If you miss it twice, get a picture of it and get it sent to that tutoring center, or make plans to go into the tutoring center or set up a Zoom meeting with them. That's going to be your best bet. And remember, there are extra practice problems in the e-text or the ebook through Cengage that you can practice, and those odd answers are included. Talk to you soon, and I hope you're doing well. Let me know if I can be of assistance. Thank you.